Hello everyone, good morning. My name is Christine Dewi. Today I will explain about the text 1, NLP, deep learning and machine learning. So this is my task is to write a Python code that trains and tests a classifier that predicts the label. And you can use the trainset to train the data and devtest to test the data and report the result. So my response to this question, first of all, I will do the read data from XML and TXT, become CSV file with convert to CSV.python. So I have my own code to generate the data from XML and TXT. First, read data XML from trainset and devtest folder because they have many files in one folder, especially for trainset and devtest. So I need to read the data first and make CSV file. After that, I will read the evidence label ABC from the trainset.txt and devtest.txt. From this code, I will generate trainset.csv and devtest.csv. We can see in here, this is the example. So I will generate the data from XML, and then the classification is from the label in the TXT file. To do this, to solve this problem, I'm doing some experiments. This is experiment 1. I also attach my code. This is the name of the code. You can check it. In this code, I merge the train and test sets, become one CSV file, and then I divide it to training 75% and testing 25%. But in here, I just experiment with article title and classification. I'm trying some models like naive Bayes, logistic regression, grid search, and then random forest, SVM, gradient boosting. The highest score is 58%. This one is naive Bayes. Okay, if we collect just article title and classification. And the next experiments, I collect the abstract text and classification using the same model, but the result a little bit different. In experiment 2, the highest score is SVM with 58.6%. The next experiment, I divided the trainset and devtest set by ourselves, based on the data set that you give to me last time. So I divided trainset and then devtest set. Okay. And I'm collect just the abstract text and do the classification. The highest model is logistic regression with 48%. With the same method, so I divide with 2 files CSV with the article title and classification using grid search. This one is 48.5%. I also experiment with another way. This one is using Distillbird. This one is the open source code file. This is the source code. I already sent everything to you. And I'm experiments with naive Bayes. The accuracy is 45%, so it's worse than the other method. And then when training using Distillbird model summary, so the accuracy is 46.9%. This one is using TensorFlow. And then in particular, note that the training data is very small. Please explain what you can do to handle such small data. So my response to this question is we can handle the small data set by implementing data augmentation. And some augmentation techniques, we can try synonym replacement, random deletion, random word swap, random word insertion. And then there are many libraries for data augmentation like text attack and LPOC, Google Trends and LP Augmentation, text augment. So if I had more time, I would explore data augmentation technique and libraries to enlarge the data set and improve performance accuracy. I also do another experiments for data augmentation. So the overall workflow for data augmentation is a set of 6 sentences are fit to the module as CSV file. And then each line contains a single sentence in English. Sentence is processed using SPECI NLP module to get the POS of each token. And then for each token from the category, synonyms are generated using WordNet. Nouns, which is not a name entity, adjective, verbs. And then once the synonyms are created for each of the tokens, the list is filtered to retain the most sensible synonym for the given context. SPECI token-to-token similarity score is used to weight its synonym. Those token pair where similarity score is less than a previously set threshold is removed from the synonym list. After the filtering process, the resulted synonyms are used to generate new sentence. Finally, the augmented data is stored to CSV file. Now, this is the code that I use to generate paraphrase. So from the list of synonyms obtained from the WordNet, we apply the similarity score to filter out non-relevant synonym. The word pair who has similarity score less than threshold is neglected. So we can set a threshold. In here, I'm using 0.40%, 0.40 for threshold. And we can explore the threshold value. The smaller the threshold value, the more variation in the sentence. For example, I have test 1 CSV. This one is the article title for our trainset CSV. And this is the praise. Okay, sentence 1, 2, 3. This is the article title. And then when I generate the paraphrase using this code, the total variation created is 4,908. Okay, so there's many variation. After that, this is the sentence 1 variation. I just show you some sample. Sentence 1, sentence 2, sentence 3. So after the article title or abstract text paraphrase finish, we can map the label again. Label like A, B, C becomes CSV file and run the data augmentation, generate paraphrase trainset. This one is for labeling. Okay, for labeling again, so we can know which one is A, B, C. And the output will be saved in output merge try CSV like this, paraphrase and classification. After all abstract text or article title is paraphrased, we can do training and testing again to see the result. And the main issue and difficulties is limited computer resources. When running the code for paraphrase, the sentence, there will be a lot of sentence variation generated, and my computer can do that due to memory problem. Thank you.